En indicates the error in the first iteration. Suppose if it is E1, let us construct an auxiliary function w of t such that w of t is equal to f of t minus Pn of t. G of x equal to 1 divided by n plus 1 factorial into fn plus 1 of zeta. Hello one and all, it is Dr. Ravi Kumar YB, Department of Computer Science, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. In today's session, you will be taught about the errors in approximation. In this interpolation, we have to find out the approximate error, that is error approximation in interpolation. Lagrange's interpolation is already taught to you all. So in that, how the errors can be determined. That is, from one iteration to the next iteration, what is the error going to be generated and how that can be determined using the method of this is going to be taught now. Now, if I consider Pn of x be the nth degree polynomial through the n plus 1 points, that is varying from x plus x0 to xn, that is xn. Similarly, En indicates the error in the first iteration. Suppose if it is E1, it is error in the first iteration. E2, error in the second iteration. E3, error in the third iteration. So on up to En indicates that error in the nth iteration. E0 corresponds to error in the 0th iteration. So if that is the case, Pn of 0 indicates the polynomial of nth degree polynomial. So if that is the case, since both f of x and Pn of x have the same values at the values of xi, where I is equal to 0 to n, that means n plus 1 points are there. So the error E of x can be written as in this form, that is En of x equal to f of x minus Pn of x. What is the meaning of f of x here? F of x is a function, that is f of x is a function. Then Pn of x, what is the meaning of Pn of x, which is already informed here, that is Pn of x. Pn of x equal to, what is f of x here? X minus x0. What is that x0 indicates? 0 indicates the x0 of 0th polynomial, 0th degree, first degree, second degree, third degree, so on up to xnth degree. So we have the terms like this. If that is the case, f of x is a function which is going to be function defined here, then Pn of x is another functionality which is of nth or nth degree. So which is going to be subtracted from is a is n nth degree polynomial. The nth degree polynomial indicates that P0 indicates x plus y. P1 indicates, that is first degree, x power 1 plus y power 0. This is degree. What is P2 of x? P2 of x, that is second degree. Second degree. X square plus 2x, something like this in the 2 dimension. If it is in 1 dimension, x square plus 2x, like this. So this is called as second degree. So similarly, if I have Pn of x, what is the nth degree polynomial indicates? X power n plus 2x power n minus 1, so on like that. This is called as nth degree polynomial. What is the error in this Lagrange's interpolation approximation? that is going to be determined with the help of E of x. That is where G of x represents this value. That is, if I rearrange the terms in the previous this, if I rearrange this term, that is G of x equal to f of x minus Pn of x minus En of x, which is equal to 0. That is the value. That f of x minus Pn of x minus this term, that is error term, which is represented by this term x minus x0. X is the value, then x0 in the 0th iteration, x is the original value, x1 is the first iteration, so on up to nth iteration, then gn of x equal to 0. So error is represented by this term. Error is represented by this term. Let us construct an auxiliary function w of t such that w of t is equal to f of t minus Pn of t. I am expressing it in terms of t now, not in terms of x. So I have t in place of x, t in place of x, t in place of x. If that is the case, w of t is actually function of t and x, because we have t here. T is a function of w. So we have now at all t equal to xi, that is, yes, xi, where I equal to 0, when I equal to 1, when I equal to 2, when I equal to n, we have x0, x1, x2, xn. Then similarly, w of t is 0 and also t equal to x. Hence we state that there are about n plus 2 zeros of w of t, because in case of w of t we have 0 here, which can be expressed in terms of t and x. That means t and x are considered here. If that is the case, we have zeros of n plus 2 zeros of w of t. That means we have n, how many items are there in this case? In case of nth term, nth order, we have Pn of x. So nth degree polynomials are there. Nth degree polynomials are there. If that is the case, in the previous slide, I also told you that nth degree polynomial. If it is an nth degree polynomial, how many terms are there? N terms are there, but totally we also include one constant, that is x square plus 2x plus 3 equal to 0. This is for second degree polynomial. For third degree polynomial, we have x cube plus 4x square plus 3, 9x plus 5. What is that? How many terms are there? 1, 2, 3 for third degree. For second degree, 1, 2, 3. For fifth degree, 1, 2, 3, 4, 5, 6. Where the other one is this, the constant. So in order to indicate that, we have these terms here. If it is nth degree polynomial, we will be having n plus 2 for, because we have w of t, which is expressed in terms of t as well as x. So we will come across n plus 2 zeros of w of t. If that is the case, we shall see to it in terms of mathematical expressions. If we impose the law of mean value on w of t, then w of t must be continuous and differentiable. Please understand this carefully. If I apply the law of mean value on w of t, then w of t must be continuous and differentiable. I am using the two words here. One of the value is continuous and the other one is differentiable. If that is the case, there exists a root w dash of t, that is the first derivative of w of t, between each of n plus 2 zeros of w of t. If that is the case, let me show you the table wherein you will see that this is the column that is representing xi. F of xi is indicated by this term, this column. Now we have the values represented along this indicates. So this corresponds to this, this corresponds to this. So we are going to consider the tables like this. Now, if I consider that there is w of n plus 1 into zeta, which is equal to 0, then I can derive the terms as d of n plus 1 divided by tn plus 1. This is a subscript. tn plus 1 is equal to f of t. I am expressing it in terms of t as well as x, because I have the two terms here, t and x, because w of t is a function of t as well as x. So I have to represent it in terms of t as well as x. If that is the case, f of t minus Pn of t. What is the meaning of Pn of t here? Pn of t is the polynomial of nth degree. Then in place of x I have t here. Then what is the error rate? Error rate must also be defined in terms of t and x. If that is the case, in place of x I have t, in place of x0 I have same thing, that is error in 0th degree, error in 1st degree, error in 3rd degree, error in 4th degree, so on up to error in nth degree, that is followed by g of x. So we have the formula like this. If that is the case, if I further simplify this, I will be left with fn plus 1 of zeta minus 0. If I bring this to this side, this becomes n plus 1 factorial of g of x. Then if I further simplify this term, what happens? G of x equal to 1 divided by n plus 1 factorial into fn plus 1 of zeta. That means if that is the case, I have x here, and if I bring these terms, that is to the denominator, it comes to g of x remains here, then this whole thing will be transferred to this denominator position. So I have the same thing here, 1 divided by n plus 1 factorial into fn of x. So this is how it is going to be simplified. If that is the case, what is en of x? This indicates that this is the error rate. This is the error rate. If that is the case, error in approximation in the nth degree polynomial is going to be determined as x minus x0 into x minus x1 so on up to x minus xn into fn plus 1 of zeta divided by n plus 1 factorial. This is how we are going to consider. Let me consider one of the example problem in which you will have to find out the accuracy of f of 0.15 for the maximum possible degree. Also, obtain a bound on the truncation error for this approximation. If that is the case, I have the one of the column, that is xi equal to 0.1, where f of xi is equal to this. When the value of xi equal to 0.1, f of xi is 0.009983. Then when the value of xi equal to 0.2, what is f of 0.2? It is 0.19867. When the value of xi equal to 0.3, it is f of 0.3 is 0.29552. So similarly, we have all these terms here, which is the given thing. Now, if that is the case, I have to find out and apply these values onto the formula. If I substitute these values onto the formula, what is the value I am going to get? Let me show you that. I have to find out the value of 0.15 because 0.1 is this, 0.2 is this. Between 0.1 and 0.2, we have 0.15. That is between 0.1 and 0.2, I have 0.15. If that is the case, that corresponds to this. This corresponds to this. This corresponds to this. This corresponds to this. So similarly, we have this 0.15. So we have these terms here, and there is one more term, that is 0.25. This term corresponds to this. 0.35. This corresponds to this. 0.45. This corresponds to this. So we have these terms like this. Now 0.25 is this. What is the value corresponding to this? 0.25. 0.25 plus 0. Half of that, 0.25 divided by 2. This is the value corresponding to this. This is the value corresponding to this. This is the value corresponding to this. So if that is the case, what is the value which is correspondent to this? So 0.35 to this, and finally we are left with this one term. So if that is the case, and if I substitute these values into the formula, I will get the value of 0.15, that is f of 0.15. So we have the value 0.9983. See here, 0.9983 for 0.1, which is the next term, 0.9884. How can I determine that? With the help of formula like this, 0.9884 into 0.15, that is the value of x here. What is the value of xi? That is 0.1. That is x0. If that is the case, which is the next value in the progress? Which is the next value? That is this 0.99 minus 0.99499,814. If that is the case, minus 0.99499814 into 0.1, that 15, that is x, minus what is the value of x1? X1 is this 0.1 into 0.15 into 0.2. That means the formula stands like this: x minus x0, x minus x0 into x minus x1. So this is how the formula goes on. Next, what is this term indicates? This term indicates this term indicates totally. This term indicates x minus x0, x minus x1 into x minus x2. The same thing is done here. What is that? X is 0.15. What is x0? 0.1. What is x minus 0? X minus x1 is what? 0.2. What is x? 0.15. What is x2? That is 0.3 in this table. In this table, it is 0.3. For the next term, which is that? I'll get this term. I will apply this and I want to find out that error. How can I do that? With this 0.0833271 into this term. What is this? X minus x0 into x minus x1 into x minus x2 into x minus x3. If that is the case, what is that x3 indicates? This indicates x3. Suppose if there is one more term, then x5. I would have taken this x5. In this case, it is x4, x3. So x0, x1, x2, x3 are considered here. What is x0? It is 0.15 minus x0, that is 0.1. Then x 0.15 minus 0.2. Then 0.15 minus 0.3 minus 0.15 minus 0.4. This is how we are going to calculate. So if that is the case, we are left with this. This has to be multiplied some value with some value. Which is that some value? It is this term. We have this term. So 0.008332171 is here. This is to be multiplied. If I simplify this term, what is the value I am going to get? If I simplify this term, what is the value I am going to get? If I simplify this term, what is the value I am going to get? If I simplify this term, what is the value I am going to get? Finally, we have this term. So how many items are there? How many terms are there? 1, 2, 3, 4, 5, 6. If that is the case, 6 terms are there. What is the degree of that? 5/5 degree. That is x P5 of x is equal to 6 terms. Am I having the 6 terms here? Yes, totally I have 6 terms. Suppose if there are P4, that is 4th degree polynomial, P4 of x, then how many terms must be there? 5 terms, that is, which includes even constant, that is this first value. Then what is P3, 3rd polynomial, P3 of x equal to 4 terms. So on like that. If that is P2 of x, then we will be having 3 terms. Because 2nd degree polynomial, so we have 3 terms. For 3rd degree, we have 4 terms. 4th degree, we have 5 terms. 5th degree, we have 6 terms. So similarly, P1 of x will be having 2 terms. Then P0 of x will be having only 1 term, which is a constant. That is this. So this is how we are going to calculate. So this is how we are going to calculate the terms. And then finally we are left with this 0.15 is equal to this 0.14943796. So the error in approximation E5, that is 5th degree polynomial, that is P5. What is the error in this? So 0.15 minus 0.1, 0.15 minus 0.2, 0.15 minus 0.3, 0.15 minus 0.4 minus 0.15 minus 0.5. We have fifth term here divided by what is the factorial? How many terms are there? 6 terms are there. So we are having sixth factorial. If that is the case, what is the value I'm going to get? The value I'm going to get in this error E5 is equal to 2.1849 into e to the power of minus 0.8. This is the value I'm going to get for the simplification, after simplification. So this is how we are going to calculate the errors in approximation, that is E5 for fifth degree polynomial. Suppose if there are fourth degree polynomial, E4 of x must be determined for fourth degree polynomial. For third degree polynomial E3 of x, we have to calculate the third degree polynomial. So similarly, E2, E1, E0. This is how approximated errors in interpolation is determined. So if you have any questions with respect to the topics I have discussed, kindly come back to me. I will be available in the department. The concepts can be clarified. Thank you very much. Thank you, one and all.